Hello and welcome to Managerial Accounting here at Stevenson University. I am your professor, Dr. B. Happy to have you with us today as we explore activity-based costing, lean operations, and the cost of quality. So, very important topic. And this relates to what we covered in the previous week when we talked about Chapter 3 and we talked about job order costing. This is kind of a continuation of that conversation because we're going to be talking a little bit more about activity-based costing as it relates to overhead. Just like we talked about in the prior week, we talked a little bit about the predetermined factory overhead rate. This is kind of related to that concept. So let's talk more about this. So, yeah, we'll talk about the overhead rates and allocations of indirect costs. We'll talk more about the activity-based costing method, and we'll also just talk about lean operations and how to be more effective when it comes to our quality in our work. So, cost distortion occurs when some products are overcosted while other products are undercosted by the cost allocation system. This happens from time to time, and oftentimes it happens because maybe we guessed on the number of units we expected to produce and we came in under or over, or we expected to sell more units and we sold less. These are the reasons why cost distortion occurs. And so it's important that we understand that. So how do we refine this? We take a closer look at our overall application of our plant-wide rate method or our general application of overhead. So let's talk about that. So here we have the plant-wide overhead rate method or the manufacturing overhead rate as it's applied to every job produced within our plant. So in order for us to do that, we use this formula, which we touched on briefly last week. This is called the predetermined manufacturing overhead rate method. And to calculate this, we take the total estimated manufacturing overhead uh, as the amount for the whole year, right? And we divide that by the total estimated allocation base. In most cases, we tend to use direct labor hours as our allocation base. And we do that because it's relatively simple and we're able to apply that uh, predetermined manufacturing overhead rate based on our direct number of direct labor hours. Very, very common method. And so I'd like to show you an example of how we would do that. So here we have some data, and we're plugging that data into our formula. So here we go. We have an estimated total manufacturing overhead for the year of $1 million. Our allocation base is going to be our number of direct labor hours for the year. In this example, it's 62,500 hours, direct labor hours. And so we plug that in. So the first thing we got to do is figure out, and it's given to us, the hourly rate per hour. So in this case, it's $16 per hour per direct labor hour. So so here we go. We have our $1 million for the year divided by our 62,500 direct labor hours, and that will give me us our manufacturing overhead rate, the single plant wide rate. So, uh, so in this case, it's the allocation it would be in this example would be 10. So we have the $16 per direct labor hour. That would be a result, right? So we got the 16 from 1 million divided by 62,500. We got $16 per hour. So we take that $16 per hour and we multiply that by the actual use of the number of hours. So $16 per hour times 10 hours used, or 10 hours for this job, gives us 160 to be applied to that particular job. So that's kind of gives you an idea of how that works. So here we have our next part of this conversation in this example. And oftentimes in business, we're met with conditions, and these conditions need to be applied to our overhead rate. So here we have the first condition. This one's different departments have different amounts and types of manufacturing overhead costs. It depends, is it right? It depends on the type of business. So here we have a bit of a difference. So if the company does have a difference, the company should strongly consider refining their cost allocation system. So here we have this diagram, and it shows that our elliptical machines, from our example from last week, requires one direct labor hour for assembly. I'm sorry, for machining, one direct labor hour for machining, and 9 hours for assembly. And this equals 10 direct labor hours total, right? And that's to build the elliptical machine. For the treadmill, it requires 4 machining hours and 6 labor hours or assembly hours. And we add those together, and it's also 10 direct labor hours for the treadmill. So 10 hours for the elliptical and 10 hours for the treadmill. So what this tells us is that it's not very different when it comes to the total number of hours, and so it's probably not going to require any type of modification to our overhead rate system at this time. So here we have a second condition that we discover, and it's do different products use the different departments to a different extent? Yeah, great question. So if the company does, the company should strongly consider refining our cost allocation system. So here we can see that the ellipticals and treadmills spend different amounts of time in each department of production. So, for example, in the machining area, it's 1 hour for the elliptical and 4 hours for the treadmill. In assembly, it's 9 hours for the elliptical and 6 hours for the treadmill. So that is significantly different for each product. So, as a result of the second condition, we might adjust slightly. We might adjust slightly. So, when it comes to department overhead rates, we try to establish separate manufacturing overhead rates for each individual department. Um, and ultimately, what this does is it kind of helps us to identify the differences between the departments with respect to the amount of hours being used in each department. So just as we saw in the earlier example, the machining department would typically take more or less time depending on the product, and the assembly department might take more or less time depending on the product. So in those cases, it's really important for us to look at applying overhead rates on a department level rather than just an entire plant-wide level. So so that's what department overhead rates is all about. So in order for us to be able to apply a department rate, we go through these four steps in the process. So the step one is to estimate the total manufacturing overhead costs incurred by each department for the upcoming year. So we want to separate those estimates out. So these estimates are known as departmental overhead cost pools. So step one, these estimates are called departmental overhead cost pools. The second step would be to select the allocation base for each department and estimate the total amount that will be used during the year. Again, the allocation base might be something like direct labor hours. Step three is we're going to calculate the department overhead rate. And to do that, we're going to take the total estimated department overhead cost pool that we got from step one, and we're going to divide that by the total estimated amount of department allocation base that we got from step two. And that'll give us the department overhead rate. And the fourth step is we're going to allocate some manufacturing overhead from each department to the individual jobs that use those departments. So in this case, we're going to take the department overhead rate that we got from step three, and we're going to multiply that by the actual allocation base. For example, direct labor hours. So those are the four steps we take in order to calculate the department overhead rate. So let's walk through the example together. So here we have the first step, which is to separate the estimated overhead rate out for each department. So as we had mentioned, the estimated total is 1 million. And so we're going to separate that out to each department. So we're going to estimate that the machining department is 400,000 and that the assembly department is 600,000. So that helps us complete step one. Step two is our allocation base. As I had mentioned, it's very common for us to use direct labor hours as the allocation base. And so we know that the total direct labor hours from our earlier example was 62,500. And so we're going to separate that out by department. We're going to allocate 12,500 direct labor hours for machining and 50,000 direct labor hours to the assembly department. And the way that we determine how that is being separated out is based off of the number of hours from each department that was given to us in the earlier part of the presentation. The third step is to determine the department overhead rate. And the formula for doing that is we take the total department cost pool and we divide that by the total estimated amount for the department, the direct labor hours. So in this case, we're going to take for machining, we're going to take 400,000 and we're going to divide that by 12,500 direct labor hours, which gives us an overhead rate for the machining department of $32 per direct labor hour. And we're going to follow that same process for the assembly department, $600,000 of estimated overhead for the year, divided by 50,000 direct labor hours for the year, giving us $12 per direct labor hour of department overhead rate for the assembly department. Okay. So, I'm showing you this on a spreadsheet just to kind of keep everything as well organized as possible. These are not typically displayed on spreadsheets. It's really just to help to convey the message to you. Although spreadsheets are helpful, especially when it comes to calculating these. So the fourth step in the process It is the allocation to each job. So we have to multiply, in this case, the department overhead rate. We're going to multiply this to the actual number of hours used in each department. So for the machining department, we're taking our department overhead rate of $32 per hour, and we're going to multiply that by the actual number of hours used. In this case, it's just one, so that gives us 32. For assembly department, it was $12 per direct labor hour of overhead. We multiply that by the actual number of hours used. In this case, it's 9, and that gives us $108. And so for the elliptical machine, that means that our total applied overhead is going to be $140 for each elliptical machine. For the treadmill, again, we take our department overhead rate and we multiply that by the number of hours used in each department to build one treadmill. So we take the 32 direct labor hours for machining times the actual 4 hours in machining for the treadmill. That gives us $128. Then we take the assembly, $12 per direct labor hour, times the actual number of hours used, in this case, 6 hours. That gives us 72, giving us a total of $200 of manufacturing overhead to manufacture one single treadmill. So, and that's how we allocate overhead using the departmental overhead rate method. So here we're looking at this block diagram, which shows us our indirect costs for the whole plant-wide rate method. And then we split that off into the different departments. So we have the machine department and assembly department. And then within each department, we have the department overhead rates, which we've identified by going through those 4 steps. And so for the machine department, for example, I got $32 of direct labor hours of overhead rate and $12 for the assembly department. And then I can apply those overhead rates to each job by multiplying the department overhead rate times the actual number of hours it takes for each job, right? And so that's how we get to the allocation of indirect cost. Yeah, so that's how that works. It's just a nice graphical representation of that. Now, as I had mentioned, oftentimes we have what we call cost distortion, and this occurs from when we have either over applied or under applied our factory overhead. And that oftentimes is because we might over or underestimate the number of units we expect to produce or the actual number of hours it actually takes. That might be more or less. And so that causes what we call distortion. The plant-wide allocation system does not pick up on the nuances of how many direct labor hours are actually used in production. And therefore, that leads to that distortion. So here we have in our example minor distortion because we over or underestimated the exact number of hours it would take. So, for example, to produce one elliptical, our actual rate was 140. We applied 160. That means we overcosted the production of one elliptical machine. And that was because it actually takes a few less hours to create one elliptical machine. And then for the treadmill is the opposite. We underapplied here. So really important to see that distinction. We we estimated 160, the actual was 200, so we underapplied our factory overhead here. And so that's where that comes from. So it's really important to really understand how cost distortion works. And again, it's oftentimes because we don't estimate properly the exact number of hours it takes for production, or the other reason might be we simply um, underestimated the total amount of overhead. So that is the application of overhead. Now I want to talk about the application of overhead from a different model, and we call this activity-based costing. This is a really specific model that we use when it comes to applying overhead. It's very, very efficient, very precise. It reduces any type of distortion. It focuses on the actual activities being conducted, meaning the type of things that we're doing in terms of production, like direct labor hours, how those hours are being used, etc. It's very, very specific. And we apply some of the basic steps that the Department of Cost Allocation does, except it's based on the actual activities being done. So earlier we talked about department cost allocation. Now we're talking about activity-based costing. So slightly different and a little bit more accurate in my opinion. So the way I'd like to walk you through this is with an example. So here we have some information that's important to understand about our company. So same company, we're building elliptical machines and we're building our treadmills and things like that. But I want you to take a look at these different activities and the related costs. So just as before, we have $1 million of manufacturing overhead that we estimate. And here we have it broken out or identified by activity cost pools. So one activity would be setting up the machines, and it takes indirect labor hours to do that, and we estimate the activity cost pool for that to be 80,000. We have handling materials, cost pool for that's 200,000. The fabrication of parts, this is soldering the parts together. We estimate that activity cost pool to be 300,000. Supervising the assembly staff, that's indirect labor, as you know, supervisor salary, 150,000. We have inspections, that's inspecting the overall equipment after it's manufactured, 170,000. And we have packaging, 100,000. And all together to get to our $1 million of manufacturing overhead estimated. So we've identified the activities and we know that their costs, but it's also important in the second step to understand the number of times, the things like the number of setups, parts, machine hours, direct labor hours, inspections, cubic feet, etc. This data, what this does is it helps us to understand how we are estimating the allocations based off of the activities. So for machine setup, it takes 8,000 setups. For materials handling, that's 400,000 parts that are being moved. For the fabrication of parts, it takes 12,500 machine hours to solder the parts together. For the supervision of the assembly, that's 50,000 direct labor hours. For the inspections, it's 34,000 inspections. For packaging, it's 400,000 of cubic feet being packaged, right? It's the cardboard, etc. So think about that for a second. So the first step we did was we identified our primary activities. The second thing we did is we discovered uh, the allocation base for each activity. And then the third step is going to be the activity allocation rate. So the third step is we find our activity cost allocation rate by taking our total estimated activity cost pool divided by the total estimated activity allocation base. So we'll go right down the line, and so in other words, we're taking the amount from step one and we're dividing it by the amount from step two. And that'll give us the activity cost allocation rate for each activity. So as we can see from our example in our Excel spreadsheet down below, is that we have a manufacturing overhead rate for each activity identified here in step three. And the fourth step is we're going to allocate some manufacturing overhead to each activity to the individual jobs that use those activities. So in other words, we're taking that activity rate and we're multiplying that we got from step three, and we're going to multiply that by the actual amount of that activity used. So actual number used. So here we have in our example, we have the allocation rate from step three, and we're multiplying that by the actual amount used. And that gives us the actual applied overhead to each activity, right? So on the top, we see the elliptical machine and the actual applied rate for each activity to assemble one elliptical machine. And that gives us a manufacturing overhead of $109 for one elliptical machine. On the bottom, we have the treadmill, and we can see through that same process, we have $212 for each treadmill. Now, if you recall what we did with the department method, is this is significantly different from the department method, right? So just by looking at the total amounts for the elliptical and for the treadmills, I can tell you that the activity-based costing method is more accurate than the department rate method for allocating overhead. So just as we had before, this is a nice diagram to kind of show us how that works. So we started with the estimated plant-wide rate of $1 million. We broke it out by activity pools, machine setup, materials handling, fabrication of parts, supervision, inspections, packaging, etc. We found out what it would be for the each activity's rate, and then we applied that to each job to get our actual application of overhead. As I mentioned, this is a great way to minimize distortion in terms of the actual cost. Now, when we compare the three different methods side by side, the single plant-wide rate method, easiest method to use, just like we talked about last week. In this case, it's 160 for each type of product that we're producing. On the department rate method, the elliptical was 140 and the treadmill was 200. It's a little bit more accurate than the plant-wide rate method. However, there is some cost distortion involved because of the under or over application of overhead based off of the actual number of hours used. And in the third method, the activity-based costing method, this is probably the most accurate application of overhead to each product produced. because it takes into consideration the actual number of hours used, and it's applied based off of each activity. So it's definitely a lot more detailed, a lot more accurate, and therefore probably the most effective when it comes to applying overhead in the manufacturing process. So those are the three side by side. So try to remember the formulas for each one because I'm sure that it'll come up on your homework assignment. You might see it again in a midterm exam. So again, just do your best to use these rates accordingly, to use those formulas accordingly. So when it comes to costing, I also think a lot about the cost hierarchy, and in this, I think about the different levels, right? So we got the factory level, just below that we got the product level, just below that we have the batch level, and then it goes all the way down to the unit level. So think about like the level of detail that you would see in a painting. So when you stand real far back from a painting, you don't really see a whole lot of detail. You see like the outlines and the shapes and the colors and all that cool stuff. That's at a very high level, right? So when you move closer to the painting, you begin to see a little bit more detail, maybe a little bit more defined lines, a little bit more definition, right? And then move even closer to the painting. Now we're talking, we can see like really compartmentalized detail within each unit of the painting. And then stand even closer, and you can see down to the minute detail from the paintbrush and the effect on the canvas, right? So that's how I want you to think about this. The factory level, super high level of very little detail, just high level stuff. That's the factory level. Then we have the product level, a little bit more detail. The batch level, good amount of detail. Individual unit level, a large amount of detail. Right? That's a way to think about this. So, an example at the batch level includes things like a machine setup. At the unit level, it's the packaging of each unit. Batch level, machine setup. At the uh, product level, activities include things like lease payments on the equipment used for the manufacturing of a product. And at the factory level or facility level, it includes the facility upkeep, depreciation, insurance, property tax, maintenance, etc. So again, high level down to the minute level. In business, it's so important for us managers to be able to make decisions based on cost. And the more accurate our costs are, the better our decision making can be. And we do this, of course, to increase our profits and make sure that our customers are very satisfied. We call this activity-based management when we make these decisions based off of our activities. So we look at pricing for and product mix decisions. You know, should I have this many products on my product mix, or is this price the right price for the market? Is it time to reduce our costs? And how do I do that by eliminating some waste, maybe, or something along those lines? And it's important for us to be able to routinely plan and control our decisions along the way. So all of these things are really great when it comes to making activity-based management decisions. When it comes to our pricing and product mix decisions, I look at my offerings that the company has, and I try to make decisions of um, whether or not to carry those products. So, for example, I have my ellipticals and I have my treadmills. I might think about eliminating one of those two product lines because it just doesn't generate enough profit. Or maybe it's a what we call a loss leader. It just does it's really just not living up to the standard and we're kind of losing a little bit of money, right? So we need to make adjustments accordingly. So we need to change prices after we identify under or over costed products, right? It might be too expensive to keep making that elliptical or that treadmill, so I might think about cutting one of those products. We need to capitalize on the extra profitability by increasing our advertising. So if I increase my advertising, the idea is that I should see a return on my investment, on ROI. And that return should be an increase in sales, ultimately, which should hopefully ultimately increase my profitability. We oftentimes end up overcosting high volume products and undercosting low volume products. And that's something we need to adjust accordingly, right? Because we want to make sure that both of our product offerings or all of our product offerings are profitable, but it's not either too high a volume or too low a volume. We want to make adjustments um, on a marginal basis, on a marginal basis. This might also involve shifting our product mix. So I might focus on producing more treadmills rather than more ellipticals because the treadmills are more profitable, right? So making those kinds of shifting decisions is really important as well. So, but the ultimate goal here, of course, is profitability. It's also very important for us to reduce our controllable costs whenever possible. And so I might need to cut costs. And I look at various opportunities to do this. I want to make sure that whatever costs I look at cutting, that it's going to add value to my customer. It's going to add value to my product or my customer, and I don't want to compromise on quality, right? So I might look at cutting some back end office stuff just to kind of remove some of that additional cost and enhance our overall profitability. So an example of this might be I'm going to my for my treadmills and for my ellipticals, I might change my packaging. I might use a slimmer box that has uh, um, less material. And what that'll do ultimately is reduce my materials packaging cost, right? So just things that we look at in business to kind of help to streamline our operation. It's important that we run our business based on a budget. Just like I talked about in the first 2 weeks of this course, every household has a budget. Every business has a budget. And it's so important that we continue to compare our budget to our actual performance in order to ensure that we're staying within our budget and that we are continuously trying to meet our goals, right? Um, that is that is one of management's core responsibilities. And you as a manager need to be able to create a budget and compare your actual to your budgeted results in order to make sure that we're meeting our goals. So, when I look at our value chain and providing great customer service and providing high quality products, I look at ways where we can manage our costs very effectively and also find ways to bring our product or service to the forefront to really leverage what we have appropriately to really get that additional profit wherever possible. So, and to do this, we oftentimes calculate the cost of consumer service to different clients. And the way that we do that is we compare our offerings, right? We'll focus on profitable products, services, and customers, and focus a little bit less on those that are a little less profitable. And we'll look at the cost of our operating activities in order to uh, eliminate some waste or try to streamline things in order to make things more efficient, right? Because that's really the ultimate goal in business is to increase our profit and reduce our expenses wherever possible. So when I look at cutting my costs and increasing my profits, I oftentimes look at the cost benefit analysis because I want to make sure that my benefits outweigh my costs, right? So benefits are typically higher in competitive markets because they have more accurate cost information and better pricing, and they're able to save on cost and really promote that product to the customer more efficiently. Those are the benefits of using activity-based costing. The benefits should always outweigh your risk. They should be higher than your risk. Um, the benefits need to be higher than your costs. Uh, when your benefits are higher and your risk is lower, the product um, will be more efficient. It will be higher in sales, etc. They might have higher indirect costs, but lower direct costs. So just think about these types of benefits, and the cost should be generally lower where the company has a greater amount of information, cost information. We have an enhanced accounting system, a good ERP. We have great data. Our technological infrastructure is efficient, etc. Our costs are typically lower because we have better data. And that's a great way of thinking about it. When these costs become distorted, oftentimes we need to look in the right places. So, why is that happening? So maybe it's because we're not bidding on jobs correctly. We have competition that is producing a product at a lower price point, but they're still earning profit, so we're being undercut. Employees might not believe the cost numbers. There's a couple of reasons why management doesn't quite understand our overall costs or our overall profits, right? So it's important that management has all the data that and they have the ability to have these types of insights. And then what this will do is it will minimize cost distortion. Sometimes the company might be using an outdated system, which leads to a need to re-engineer it to make things more efficient. Which leads me to my next talking point, which is the need for a company to be efficient in their operations. We need to maximize profit and reduce our costs. By doing that, we become what we call more lean. We're thinking about the profitability. We're thinking about our customer and the overall quality that they're receiving at a lower price point. Right? So these types of things, we call this lean thinking, right? A lot of businesses today, they're trying to be as lean as possible, reduce as much waste as possible. That's what it means to be lean. And in being lean, we want to avoid this thing called downtime because with downtime, there's too much waste, right? In manufacturing, we don't want downtime. That's bad, right? In business, we don't want downtime. That's bad. That means we got two idle hands. So here's what downtime stands for. The D is for defects. O is overproduction. Waste is waiting. N is not utilizing people to their full potential. D is for transportation. I is for inventory. M is for movement. And E is for excess processing. Now, when we talk in class on Thursday, I'll definitely talk to you more about this, but I want you to really think about this for a second. Think about the manufacturing process. Think about that example I showed you in class about the automobile. When it comes to the movements that both the people and the product make, the less movements there are, the more cost we'll save, right? So just think about these things. Think about how to be more efficient when it comes to business, how to be more efficient when it comes to manufacturing. I had brought this up several times in class, and I'm going to keep bringing it up. It's called just-in-time manufacturing. I had mentioned that Toyota invented what we call the Keiretsu system, which is just-in-time manufacturing. It focuses on when we purchase our materials. We do it just in time for the production to complete the goods just in time for the delivery to the customer, right? What that does is it eliminates the need to carry inventory. It eliminates any wasted time, and it streamlines the process. It adds value to the customer's experience. So, yeah, think about just in time. Think about how it modernized the way that we manufacture things. How does it reduce cost? How does it eliminate waste? Right? Think about these things. It's so important that we are efficient in business operations. So, great characteristics here of lean operations in business, continuous flow. Think about the assembly line, the pull system, shorter manufacturing cycle times, small batch products, reduced number of setups, the point of use, where are we storing things? How many times is it being moved? Supply chain management. Do we have our raw materials readily accessible? Backflush costing. These are all characteristics of lean operations. We'll talk more about this in class. The drawbacks to lean operations is that sometimes it leads to delivery delays. There might be weather-related issues that impact our supply chain. Strikes can occur where the employees have been unionized and they go on strike because they want higher wages or whatever. There might be shortages of parts or recalls even of parts. So these are some drawbacks to lean production because we don't have extra parts sitting on the shelves. When it comes to sustainability and lean thinking, think about what the impact is from an ESG perspective. Think about the environmental, social, and governance. How do we reduce waste? How do we think about our economic profits? How do we reduce internal waste? I and what's the overall impact on our planet and on our society? Right? These are things we need to think about in management in order for us to be both sustainable and profitable. which leads us to the next concept we call total quality management. This is the management philosophy to focus on consistently generating high quality products. So, how do we generate high quality products? Well, we eliminate waste, we increase our profitability, and the way that we do that is we have a product that we developed using awesome direct materials, our direct labor is top notch, and our factory overhead is lean, right? So, having those three things helps to produce high quality products. The goal is to provide the customer with superior product and service. So we want to maintain the service after the fact by providing the warranty and the follow-up, etc. And each business function in the value chain examines how the activities to improve the quality and eliminate any type of defects. This goes back to ensuring that we have a high quality product. So, how do we do that? We break down the product through a quality control process to ensure that each mechanism in the product is working the way that it's supposed to and that there's no defects. Which leads me into my next point, which is the cost of quality. It can be expensive, right, for us to produce a high quality product because we want to use the best materials, the best labor, and be able to control our overhead. So we oftentimes need what we call prevention costs, and these are quality control costs that we use to prevent any type of defect, to prevent any type of recall. We have what we call appraisal costs. These are incurred to detect poor quality goods and services. We kind of need to reevaluate oftentimes our products to make sure that they are of high quality. We do that through what we call appraisals. We have internal failure costs. So this is what happens when we discover defects before they're delivered to the customer. And so we need to retool our product in order for us to make sure that we're not delivering a product that's going to fail. Now we have our external failure costs. This happens when we discover a defect, but it's too late. We don't discover it until after the product has been delivered to the customer. And this leads to reputational damage. It leads to a return of the product. It leads to refunds, exchanges, etc., which ultimately leads to higher costs for the business. So these four types of costs are things that can be controlled, and they are oftentimes under scrutiny because we need to make sure that we're not experiencing additional costs from them. These are the types of costs that stem from the prevention costs, appraisal costs, internal failure costs, and external failure costs. Under prevention, to prevent costs from happening, we need to train our employees, evaluate our suppliers, use better materials, use preventative maintenance, etc. These are preventative measures. We're preventing the product from failing. For the appraisal costs, those types of costs include things like inspection of materials, the inspection at various stages of production, product testing, etc. Right? Those are the appraisal costs. We're testing to make sure that our product is of good quality. We're appraising it. We have our internal failure cost. This is the cost of reworking the product, a cost of scrap, the disposal of rejected units, etc. Right? We've noticed the failure before it got to the customer. That's an internal failure cost. These costs stem from internal failure costs. And then we have our external failure costs, the cost of recalls, the cost of returns of the product, warranty costs, the cost of dissatisfied customers, the reputational damage that occurs, potential lawsuits, etc. This is when we delivered the product to the customer and there's a defect. We didn't realize it in time. It's external failure. So it's so important that we try to maintain these costs and that we identify where they occur, and we work collectively to ensure that these types of things don't happen in the future. Here we have an example of the type of costs that are incurred and how we measure them in relation to our quality control measures. Uh, so we recognize the cost incurred as a total cost of quality. We add up all of our costs incurred and get to our total costs of quality. And then we express that each area as a percentage of the total cost of quality. And we do that pretty simply. We take the uh, total cost of each area, like for example, total prevention costs. We take that amount and we divide that by the total cost of quality to get the percentage. Yep. Uh, and this is useful because it shows us in management how to be more effective when it comes to controlling our cost. So here we have an example of this. So after we review the report, we're considering these costs, and and so it's important that we're able to make those changes based on the results of those internal and external failures. And so here we see that example broken out by those changes implemented as a result of those internal and external failures. And because of those changes, we hope that we would see a total cost savings. See? So in looking at all that data, it's really important for us to be able to analyze the information as managers through data analytics using tools uh, like artificial intelligence, like R squared, like other statistical methods to identify correlations, identify strengths and weaknesses, in order for us to be able to make effective decisions. To do that is, of course, using Excel. We can use a correlation coefficient in Excel in order for us to demonstrate the relationship between the cost and the outcome, right? So the correlation feature in Excel really, really efficient. And so I commonly use this correlation feature in order to determine those types of relationships. I find it to be very useful, and I encourage you to use it as well in Excel. And if you have any comments, questions, or concerns about that, just feel free to reach out to me. I'd be happy to help you out. Thank you so much for your time today and listening to this presentation. This presentation is posted in the classroom. I want you to use this presentation to assist you in your homework assignment, and we'll also have class, but I just want you to know that although we didn't have our class in person today, we will have it in person on Thursday, and I will certainly be there to guide you along the way and to help you to understand this content. So thank you so much. I appreciate all of you. Have a wonderful rest of your day. Take care. Bye bye.